everyone, welcome back, and today we're going to be talking about the big 5 kinematic equations that I think are essential that you know for this class in order to pass the test. And this video was supposed to be uploaded a while ago, but I'm getting around to it now, so it's fine. Now you might be asking yourself, well, when exactly would I even use these equations? Well, you'd use these equations when you're dealing with problems involving motion, and you're going to want to use these equations only when you have constant acceleration. Now, constant acceleration means that it's not changing, aka something is speeding up or slowing down at the same rate every second. But you don't have to worry too much, because usually for this class, acceleration will be constant. These equations are super helpful when you're given 3 variables and you need to find a 4th, or you're dealing with things that are speeding up, slowing down, or falling objects. Now, here's a little cheat sheet of all the symbols just in case you don't know what they mean, so I'm going to go over them real quickly. Now, V represents final velocity, or how fast you're going at the end. V with a little oval at the bottom represents initial velocity, or how fast you were going at the start. A represents acceleration, T is time, and delta X is displacement, how far you moved, and in which direction. Now, if you're ever unsure what formula to use or what equation to use when you're given a problem, well, you're going to take all the information you're given, and then you're going to see which equation only has one unknown, and then you'd pick that equation and just solve for the unknown. And another thing that you're going to need to do is sometimes you will need to rearrange these equations to give you new equations so that you could solve for your variable. An example of that would be with this equation here. We have final velocity is equal to initial velocity plus acceleration times time. Well, if we want to isolate a variable, we just minus initial velocity to put it on the other side, leaving us with this, and then we just divide by a, and that will cancel, basic algebra, and then we've officially isolated our t variable. And now we could solve for that if we had all these other variables right here. So the first kinematic equation I want to go over is this one right here, where final velocity is equal to initial velocity plus acceleration times time. Now this formula is good for when you're changing velocity over a certain period of time. Now let's just use an example. Say you start at 2 meters per second and accelerate at 3 meters per second squared for 4 seconds. What's your final velocity? Well, we will just plug in our variables because v is what we're solving for. So our initial velocity was 2. We accelerated for 3 meters for 4 seconds. And if we do all that math, that'll give us 14 meters per second as our final velocity. Now, equation 2 is perfect if you know both your starting and ending velocity and you just want to find displacement. So this equation is displacement is equal to 1 over 2 times final velocity plus initial velocity times time. Now let's do this example. Say you start at 2 meters per second, you end at 6 meters per second, and you move for 4 seconds. And what is your displacement? Well, once again, we're just going to go ahead and plug in. So since our final was 6 and our initial was 2, and then we're just going to multiply that by our time. And that will give you 16 meters as your displacement. Now let's move on to equation 3. We have delta x is equal to initial velocity times time plus 1 over 2 times acceleration times time squared. Now this equation is good to use when you don't know your final velocity, but you do know time and acceleration. So let's take this example. Say you start at 0 meters per second, you accelerate at 2 meters per second squared for 3 seconds. Well, once again, we're just going to plug into all of our variables, and that will give us 9 meters as our displacement. Now for equation 4, this is rarely used, but it is good for when you don't know initial velocity, because you know the other 2 equations for displacement do need initial velocity. So if you just know your final, you could use this one. And this one is displacement is equal to final velocity times time minus 1 over 2 times acceleration times time squared. Now, equation 5 is good for when you don't have time. And equation 5 is final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. Now let's do this example. Say you start at 0 meters per second, you accelerate at 5 meters per second squared over 10 meters. What is your final velocity? Well, once again, we're just going to go ahead and plug in what we're given, square root it, and we end up with final velocity is equal to 10 meters per second. Now, say you had this equation, but you wanted to find this variable instead. Well, you could always rearrange the equation using basic algebra. Just thought I'd mention that. Now, excuse this poor drawing, but the next thing I want to talk about is free fall, aka motion under gravity. Now, free fall is just when the only force acting on something, like this square here, is gravity. No air resistance or other variables. And free fall can be any time when something is dropped or thrown straight up or down under gravity. Now in these, when you're given a free fall problem, we treat gravity as a constant. And we always use 9.8 meters per second squared as acceleration due to gravity. And we add the negative sign because it's going down. So let's do one free fall problem. So a ball is thrown up with an initial velocity of 20 meters per second. How high does it go? Well, the first thing we're going to want to do is write down what we know. So we know that initial velocity is 20 meters per second. We know that velocity is 0 meters per second because when something is thrown straight up at the very peak at the top for a short amount of time, the velocity is 0 meters per second before it comes back down and velocity turns negative again. And our acceleration is our gravity constant, and what we don't know and what we're looking for is our displacement. So based on all the information we're given, we're going to go ahead and use this equation here. Now we're using this equation because we know what our final velocity is, we know what our initial is, and we know what our acceleration is. That leaves us with our delta x is unknown, which we could solve for. So when we start to plug in all of our knowns, we just multiply it out, subtract the 400 to get it on the other side, and then finally we isolate our delta x, resulting in 20.41 meters. Now, this all seems pretty simple. It's just rearranging, finding your unknowns, and plugging in. What people most have trouble with is picking the equations, but you just pick the one that gives you the one unknown variable. You don't want two unknowns and a problem, or else you won't be able to solve it. Anyways, some quick tips are to always list your known variables, pick the equation that fits, your units should match, and you want to pay attention to your signs. Now, I know that was a lot, but this stuff is important, so I hope you paid attention, and I hope you come back for my next topic.